In this video, we're going to go over even and odd functions and how to determine whether a function is even or odd algebraically. So your even functions have y-axis symmetry. They have what their opposite inputs equals their original outputs. And when we solve this algebraically, we'll do f of negative x equals your original function, f of x. So from last lesson, we had this in it. Your even functions are again with your y-axis symmetry, which is what we have here. And then we have opposite inputs equal your outputs. So when we put in negative x, we would still get a y back. Right? If I had 3, -2, and I put in the opposite input of -3, we still got my same output back. And so as a reminder, your y-axis symmetry means that it mirrors over on that y-axis, using that y-axis as a mirror. And then we have odd functions. Odd functions have origin symmetry. Opposite inputs equal opposite outputs. And when we solve this algebraically, we'll do f of negative x equals my negative f of x. So this was from last lesson as well. And it goes over kind of the exact same things. Your odd functions is origin symmetry. Opposite input equal opposite outputs. So when you have x, y, and I put in an opposite input, I get that opposite output back. When we had the 0.32, the opposite input of -3 gave me the opposite output of -2. And as a reminder, origin symmetry means that if you take your graph and you rotate it 180 degrees, you still have the same graph. So when I'm determining algebraically whether the given function is even, odd, or neither, so we don't really care about x-axis symmetry, what I am going to do is do f of negative x and see, do I get my original function back? Do I get the opposite version of my function back? And if I don't get either of these, then it's a neither. So here we go. We have f of x equals 4, or x to the 4th power minus 2x squared plus 3. To determine if this is even, odd, or neither, I'm going to do f of negative x instead of f of positive x. So now instead of all of these x's, I need to replace it with negative x. So this is negative x in parentheses to the 4th minus 2 times negative x squared plus 3. So let's simplify. If I have a negative number and I take it to the 4th power, that's going to make this positive. Because negative times negative is positive, times negative is negative, but times another negative makes it turn back positive. Then I have -2 times negative x squared. Same thing here. If you have negative times negative, that's going to turn out positive. So positive times negative makes us a negative 2x squared. So basically, when I say we're simplifying, I'm simplifying the signs, right? What's positive, what's negative. And then nothing changes here, so I'm just going to bring down a plus 3. So when I look at this, I need to compare it to my original f of x. When I put in a negative x, does it equal my original or the opposite of my original, or neither? Well, I can see here that 4x, x to the 4th minus 2x squared plus 3 is the exact same thing as my function. So here, when I put in a negative x, it came out to the original. When this happens, that makes this an even function. You can kind of use your calculator here, and I say kind of, but you definitely can. You can use your calculator to help you determine if this is even or odd. So I'm going to go in here to graph this. And we've got x to the fourth minus 2x squared plus 3. And I'm just going to start by graphing it on a standard. So I'm going to go zoom 6. And there's my equation here. I know that even functions have y-axis symmetry. Does this graph show me that it has y-axis symmetry? Yeah, if you take it here and you flip it over here, it's going to map on top of itself. So I know that this is correct. This is even. So you can use your calculator to verify your findings. But you do have to show me your work if it says determine algebraically. Okay, let's do the same thing here. I'm going to plug in negative x for my x and see if I get the original, the negative version, or neither. So everywhere I see an x, I'm going to replace that with negative x. So I've got 3 times negative x over 4 times negative x squared plus 6. I'm going to keep simplifying. And by simplifying, I mean I'm just worrying about signs here. Positive 3 times the negative x is negative 3x. Negative x in parentheses squared is positive. Positive times positive is positive. So we got 4x squared, and then bring down your plus 6. Another way to write this right here is by taking this negative and pulling it out front. So this is equivalent to negative 3x over 4x squared plus 6. So, and I maybe should have said f of x, possibly, really doesn't matter. But my function's g of x. I'm going to change this to g of x. Okay. So when I plugged in g of x, did I get my original? Do these two here match? No. Whichever version you look at, you either got an extra negative here or you got an extra negative here. So it's not this one. Did I get the negative version of my function? And that's why I rewrote this one this way. If you can see that this is this, then that's fine. You don't need to rewrite it, but this is more visual. That when I plugged in my negative x, if I get my negative function, and I do because I have this exact same function, but now I have a negative out in front of it, this equals negative g of x. So because of this, that means my function here is odd. Okay, so let's check this in our calculator. When I put this in, I've got 3x divided by, I'm dividing all of this. I need to put this in parentheses. 4x squared plus 6. And I graph it. Okay. I've got very small things going on here. So let's zoom in a little bit. You can go to your window if you want and change your window, but a really cool function here is if I'm just wanting to zoom into this portion right here, I'm going to go zoom and I'm going to hit Z box. and I can make a box to where I want to zoom in at. So if I want to zoom in kind of this portion here, I'm going to start in a corner. I'm going to hit enter. And then I'm going to go down and over, and it makes a box, and I can zoom in on this portion of my graph. So I'm going to hit enter once I got my box. And there's my graph. We said that it's odd, and odd functions have origin symmetry. So if I take this graph and I rotate it, do I get origin symmetry? Yes. This graph is the same as this graph. So I know I did this right. Use the graph to your advantage and check your work. But again, I've got to see your work to determine algebraically. But once you do the algebra, you can use the graph to help you determine, whether it's even, odd, whether you get the same thing or the negative version. Okay, and then C. So now we have h of x. So I'm going to go h of negative x, because that's what I'm doing. I'm replacing x with negative x no matter what. So I've got negative 7 times negative x cubed minus 5. So simplify this, and by simplify, I mean change your signs. Negative x cubed is negative, because negative times negative is positive, but that third negative makes this negative. And negative 7 times the negative x makes this a positive 7x cubed, and then that minus 5 comes down. This is why I want you guys to use the calculator to help you if needed. This one here, we can obviously see that h of negative x does not equal my original h of x. Okay, I'm checking for even, and I can clearly see that this does not equal the original because this is positive and this is not. H of negative x also does not equal h of x. For this to equal negative h of x, you would have to have negative 7x cubed minus 5. When you distribute that negative, you would get positive 7x cubed plus 5. I've got positive 7x cubed, yes, but I have a minus 5 and I should have a plus 5. So it does not equal either of these. So that makes this one here neither. If your algebra skills are not super strong, these are sometimes hard to understand. This one's always easy. Does it equal the original? Yes or no? I can see that this one is obviously the same, and I can obviously see that this is not the same as this. But this, does it equal the negative function? It's sometimes hard to differentiate, because this one here had one negative out here, and it is opposite, but this one here took away that negative, but it's not opposite. And so when you put this in your calculator, negative 7 cubed minus 5, let's go back to a standard. I can see that that's not either. I mean, that's not even x, but it's not y, and it's not the same when you rotate it here either. So it is neither. And so if you can at least do the algebra portion here and tell me what f of negative x, g of negative x, h of negative x, if you can at least tell me what they equal, then you can kind of help yourself, or let the calculator help you determine if it is even, odd, or neither, by then determining, does it have y axis symmetry, origin symmetry, or none of the above.